Alright, this lesson is about solving exponential equations. The overall goal is going to be to write each equation so that it has the same base. And right away I see there's a typo in problem number 1. This x right here should be the x power. So let's pretend that didn't happen. In fact, I'll white it out. Okay, that's what this equation is supposed to look like. Now, we have to use a little bit of common sense. If the bases are the same, that's only going to, this equation will only be true if the exponents are the same. So I see that I've got 6 and 6 are my two bases. That means these exponents would have to be the same. I mean, it wouldn't make sense if I had 6 to the, say, third power, and that was equal to 6 to the question mark. What would this question mark be? Obviously, it would have to be 3. Okay? It wouldn't make sense to have 6 to the third power over here, and then have 6 to the fourth power over here, and yet I'm claiming that they're equal. That wouldn't make sense. So, common sense tells you that the only way, if the bases are equal, the exponents are going to have to be equal. That's the only way. So that's what we're thinking about here. Since the bases are equal, the x's are going to be equal. The exponents are going to be equal. So that means x has to equal 3x minus 4. Now my students will say, oh, so does that mean you just cancel out the 6's? No, technically we're not canceling out, because canceling out implies division, and we're not dividing. We're just using a jump of logic. That's all it is. Okay, so by logic, technically not canceling, these exponents will be equal to each other. And then you just solve like normal, getting this x by itself. So I would subtract 3x from both sides to get these terms together. Alright, so those are gone. This makes negative 2x equals negative 4. Then you're going to divide both sides by negative 2. Okay, so you're going to wind up with x equals 2. Alright, now if you wanted to check your work, you could. Alright, if you went and plugged this 2 back in for x, you could check to make sure that makes a valid solution. Okay, so this makes, if I put 2 in for x, that makes this 6 squared. If I put 2 in for x right here, then that makes this 6 to the 3 times 2 minus 4 power. So this is 6 squared. Right. I just mean for today. So this is going to be, so that'll be 6 minus 4, which of course makes 2. So 6 to the second power obviously equals 6 to the second power. That's how you check your work if you feel like it. Alright, looking at number 2. Again, we have like bases already. That's only going to be true if these exponents are equal. So that means x plus 3 will equal x plus 3. Well, that's just common sense. You know, this expression is the same on both sides. This is a special case. When you have a statement that is just a statement of fact, you know, like a equals a, x plus 3 equals x plus 3, something equal to itself, that's a sign that this is infinitely many solutions. Infinitely many solutions. Alright, that doesn't happen very often, but watch out for that. If you were to follow through and try to solve for x, all of these x's would cancel out, and you'd be left with 3 equals 3. Alright, again, when you see this, that means infinitely many solutions. If this had turned out to be a false statement, like 3 equals 0 or something like that, this would mean no solution. Alright, but since we have 3 equals 3, that's infinitely many solutions. Alright, let's go ahead and do number 3. Hopefully it's a little bit more normal. So looking at number 3, again, I was nice and I gave you these expressions that already have like bases. So that means the exponents should be equal to each other. So 3x should equal 2x plus 1. If I subtract 2x from both sides, that just gives me x equals 1. Boom, done. Alright, let's find number 4. Okay, now this one's going to take a little bit more thought. Two different bases. I need to rewrite this larger base using the same number as the smaller base. So, how can I rewrite 4 using a base of 2? Well, I'm hoping it's clear to you that 4 is the same thing as 2 squared. So if I write it that way, I'm in business. And of course over here I still have my 2 to the x plus 3 power. Alright, so there's my x plus 3. Now, so what do I do? So I've rewritten 4 as 2 squared. So what do I do with this x minus 2 over here? Well, if I were you, I would just put it in parentheses for right now. Because what we're going to do in a moment is distribute. So what I got now what I can go ahead and do, since the bases are equal now, I now know that the exponents will be equal. So I know that x plus 3 is going to equal this other exponent. I'm going to go ahead and do the distributive property though and put 2x minus 4. Okay, but I'm setting this exponent equal to this exponent. So now I just solve as usual. Subtract x from both sides. So that gives me 3 equals x minus 4. And then I will add 4 to both sides. So that gives me x equals 7. Alright, so that's the answer to number 4. We'll need to do the same thing for number 5. I have 2 different bases. I recommend taking the larger base and trying to rewrite it using the smaller base if you can. And I can, because 9 is 3 squared. So over here I'll have my 3 to the 4x power. But over here I've got 3 squared, and then I've still got this x plus 1, which again I will put in parentheses. Now logic tells me that the exponents must now be equal. So 4x must equal 2x plus 2. What happened to the 1? I did the distributive property. So now I have 2x plus 2. Solve as usual, subtracting 2x from both sides. So I get 2x equals 2, because these are gone. And then I will divide both sides by 2. And that gives me the final answer of x equals 1. Alright, let's take a look at number 6. Now I've got a base 4 and I've got a base 16. Is there a way to rewrite 16 using a base 4? Sure there is. 16 is 4 squared. And then I'll keep my x plus 1 over there. Then over here I will have my 4 to the 8x minus 4 power. Now that the bases are the same, logic tells me that the exponents must be the same. So x minus 4 must equal 2x plus 2. I did the distributive property here. So getting the x's together, I will subtract 2x from both sides. So that'll give me 6x minus 4 equals 2. These are gone. Then I will add 4 to both sides. So that will give me 6x equals 6. Dividing both sides by 6 equals 1. Alright, so that's number 6. Alright, back to super easy. The bases are already the same, so this is, I can go ahead and set the exponents equal to each other immediately. So x plus 3 must equal 2x minus 4. Subtracting x from both sides, that's going to give me 3 equals x minus 4. Adding 4 to both sides, that gives me x equals 7. Okay, I hope that wasn't the same problem as before. So I see that 7. Okay, kind of the same problem. Anyway, moving on. Looking at number 8. Again, the bases are the same, so this is ridiculously easy. 3x equals x plus 2. Subtracting x from both sides gives me 2x equals 2. Dividing both sides by 2, and I see that x equals 1 again. Alright, these problems are not particularly challenging. Again, the bases are the same, so 2x plus 1 must equal, 2x plus 1 must equal 3x minus 3. Subtracting 2x from both sides gives me 1 equals x minus 3. Adding 3 to both sides gives me x equals 4. Alright, I hope these next problems are more challenging than that, because that's lame, lame, lame. Alright, now these bases are not the same, so I will have to convert this one. So I can write 4 as 2 to the second power. I still have my 3x minus 3. And over here I have my 2 to the x plus 4 power. Now that my bases are the same, logic tells me that the exponents are the same. So 6x minus 6 must equal my x plus 4. Where did all these 6's come from? I distributed the 2. Collecting the x's by subtracting. So subtract x from both sides, so these are gone. So this gives me 5x minus 6 equals 4. Man, that looks like a y, but it's 4. So now I will add 6 to both sides, my friend. So that's going to give me 5x equals 10. So if I divide both sides by 5, that gives me x equals 2. That is how this works. Alright, look at number 11. These bases are not the same. I need them to be the same. So I will take this 25 and I will rewrite it as 5 to the second power. Here I will keep my x minus 2 in parentheses. Over here I've got my 5 to the x plus 2 power. Now that the bases are the same, logic tells me that the exponents are the same. To wit, x plus 2 must equal 2x minus 4. Wait, where did the 4 come from? I did the distributive property. Got to get those x's together by subtracting. So subtract x from both sides. That gives me 2 equals x minus 4. Adding 4 to both sides gives me x equals 6. Alright, look at number 12. I think we're getting to the end of this lesson. The bases are not the same, so I'm going to take the bigger one and rewrite it using the same base as the smaller one whenever I can. So I can do that because 9 is the same thing as 3 squared. And then I still have my 4x plus 3, so I put that down. On the left side, I still have my 3 to the 9x power. Now that the bases are the same, 3 and 3, logic tells me that these exponents are the same. So 9x must equal 8x plus 6. I got the 8 and 6 by doing the distributive property. Getting the x's together by subtracting. So I subtract 8x from both sides. Alright, so those are out. 9 minus 8 is 1, so x equals 6. Okay, was that the last problem? Alright, that is it for this lesson. Watch the next video coming up for more advanced problems. Alright, in this lesson we didn't work with any fractions which produce negative exponents, and we didn't have any problems where we had to change both numbers. The most we had to do was change the bigger number, and we knew exactly what to change it to. But there are problems where we will have to change both bases, and we will look at those at the next lesson. I hope this has been helpful to you. If so, a like is always appreciated, and I will see you on the next video.